Welcome to the Torsion Pendulum video. In exercise 1, we'll be setting up the apparatus.
Start by connecting the rotary motion sensor to the screw adapter. Connect the other end to one of the torsion wires. Hang the assembly from the platform. Using a stand and some cross pieces, fasten the rotary motion sensor in place. Try to keep the wire straight and fully extended. Tie some string around the rotary motion sensor's pulley and wind it such that pulling the string will twist the torsion wire.
Connect the rotary motion sensor and force sensor to the data acquisition interface.
In exercise 2, we'll be measuring the torsion constants for each of the 3 torsion wires.
Open Data Studio and select Create Experiment. Click Channel 1 and add the rotary motion sensor. Change the sample rate to 100 Hz. Click Channel A and add the force sensor.
Double-click Graph and select Force. Change the x-axis to angular position. Press Start in Data Studio. Press Tear on the force sensor. Hook it onto the string, and pull such that the torsion wire twists in place. Press Stop. If all goes well, the first section of your data should be linear, and you can discard the rest.
In exercise 3, we'll be measuring the periods of oscillation for several different masses in different rotation axes on several different torsion wires in order to find their moments of inertia.
Measure the dimensions of each object. These will be necessary for a direct calculation of the moment of inertia.
To calculate the moments of inertia, it will also be necessary to measure the masses of each object.
Remove the rotary motion sensor and stand from the system. Attach one of the masses to the torsion pendulum.
You will need to attach a trigger to the mass so that you can monitor its twisting motion using a photogate. Possible options include a tape flag, a pencil, or a piece of paper. Place the photogate nearby and orient it in such that the trigger passes through. Replace the rotary motion sensor in port 1 with the photogate.
Click Setup and remove the rotary motion sensor from port 1. Replace it with the photogate and pendulum option.
Double-click Graph and select Period to create a plot of period versus time. Twist the mass and release it and press Start to begin recording data. Note that the trigger must pass all the way through the photogate to use the period option as shown.
Repeat this procedure for a different rotation axis by attaching the torsion wire to a different point on the mass.
Continue to repeat this process for all the regular shapes and their different rotation axes.
Additionally, repeat this process for each of the 3 torsion wires.
In exercise 4, we'll be determining the moment of inertia of an irregular object.
Attach the irregular object to the torsion wire.
Estimate the effective radius of the irregular object and measure its height.
Repeat the same procedure as exercise 3 to find the moment of inertia of the irregular object.
A photon walks into a hotel. The bellboy asks if he can take its bags. The photon says, "No thank you, I'm traveling light."